Right. Now proper explanation here, recursion. It's a case where if you look in this example, you have a route, and without configure. But route iroro, its next hop IP is not on a directly connected network. Right. So you can see from RTA, and then a route randaisa manually, it's a static route. We can see with destination yayo ndo irapa. We can see the next hop iri ndo irapa. But the problem iripo ndeyekuti ndikabva pana RTA ndichida kuenda next network iyi handijambe apa kuya panapa panext hop ndinofanira kuwana a directly connected interface iri next hop yangu inofanira kunge iri apa iyi. That's the problem. Saka inonzi root recursion is a case yekuti we now have to have another route configured rinotisvitsa panapa. So route redu ndoriri pasecond example iri. Let me try to remove this first. Right. Route redu ndoriri apa. So this was the first route rataconfigure. But zvanga riri kuita ranga riri kuda kutisvitsa panapa. Kubva panapa richienda kunojamba kunosvika apa direct as the next hop. Next hop is not here, but directly connected interface ready. That's a problem. So we use a recursion yekuti we now have another route which directs us kusvika pane next hop yedu ndo apa via exit interface iri apa via next hop iri apa ndo iri apa. So the definition yerecursion now maroutes aya kana ari 2 kuti ndisvike panapa first lookup inotarisa ishi yobva yatarisa next hop ishi but yobva yashaya ishi on a directly connected interface, then yoita a second lookup ichishandisa this one yobva yasvika pa up via this next hop IP address. That is basically what recursion is. But I think it could be worth avoiding. I'm not sure practically how it works. But if I was to configure network E, it would make sense kuti kana ndoda kusvika ku-destination network iyo kana ndoda kuconfigure route rinondisvitsa panapa from this network, it would make sense configure a route rinoti 30.1.2.0/24 ndoisa exit interface 10.0.0.2. Then panapa, so iri rinenge riri static route apa, then panapa ndoisa rimwe static route riri kuti 30.1.2.0.24 exit interface roita 20.1.1.3. I think it makes sense. I'm not so sure what's the use. Yeah, route recursion EO. If we can have something simplified like this, I think it's something to investigate. Why have this instead of issues and database? something to investigate. But route replication, if you can summarize it in having multiple lookups, 2+ lookups on the routing table. Kakawanda destination network ndinongotarisa entry inomecha then ndakutoforward ikoko. But for route replication, that's not the case. Unotarisa entry inomecha, but yamecha or not next hop haipo pama directly connected interface. Then we have to have a second look at the routing table yako so that you can find the next hop iri panapa iyi kuti unosvika sei ipapo using this. So that's multiple lookups. I think that is what defines recursion basically.
Sorry, sir.
Yes.
So in other words, kuedza kureva kuti pa root recursion apa inenge yakada kufanana nezvinoitika muma MPLS networks zvezve-label switching, kuti zvoni the next router iri kutanga yareader kuti zvoni do I have this destination address, and then kana iri nayo yozotsvaga ku the next hop. Is it the concept iri kushanda ipapo?
Recursion.
Mm.
I'm not so sure. I think we'll have to visit MPLS. I'm not familiar. I am a bit, but not near recursion. I know of label switching and all, but not so sure about recursion now. MPLS recursion, I'm not so sure. I would lie. But it's something you can look at. Do not irregular recursion ku MPLS.
Okay, sir.
Hello. Hello.
Okay, send up about ipapo.
Regatidai so. MPLS recursion. It might be the same thing. No. Label switching. No recursion. Simple lookup. Control plane. Yeah, don't want to complicate. Excuse me. Don't want to complicate us in a little bit. But I think I'll answer that question for you. Probably inbox. I'll have to take a look at MPLS. Don't know, is it the same concept illusions for now? Right, let's go to equal cost route. When there are equal cost routes in the IP routing table, a router forwards IP packets to be sent to the destination subnet through all valid outbound interfaces. And the next hops in the equal cost routes achieving load balancing. Okay, equal cost routes, it's a case now where we have a router with 2 or more paths that leads to the destination network where they have the same preference, they have the same cost. It means we cannot separate maroutes one. Therefore, pachaitika load balancing. So instead of using one path, router red will use all of those paths simultaneously, and basically that is what load balancing is. So when you look at equal cost routes, think of load balancing because you cannot separate two routes one. In my head, I'm thinking, after the MPLS, yeah, very more.
Yes, sir.
Those are it is what you want, MPLS. Ndimo is the MPLS game. Those are it.
Hatisati tasvika ikoko. Hatisati tasvika ikoko.
Yeah. My service providers no one wants to answer MPLS. I think it's quite an interesting technology. My service providers here. Let's go to floating routes. A floating route is basically a backup-ish. It's a backup. How do we have a backup route? Different preferences can be manually configured. Therefore, you can configure two static routes, same destination, different preferences, and the next hops to implement backup or forwarding paths. A backup route is known as a floating route. Example yatinayo, we want to get to this network, dot destination area. We can either go from RTA via this direction or via this direction. So first route rangu randinoisa, this is not the backup, the OG route. Getting to 20.0.0/30 via the next hop IP irapa ish do uko. So ndikuenda nekunoko. Static route a preference of 60. Right. Then configure another static route. In this case scenario, ndobva ndaichinja the default preference ye60 ndobva ndanoisa 70. Because my preferences, you can manipulate them. Ndokwanisa kuisa a route ndobva ndachinja preference. So in this case, ndandaisa rimwe route to the same destination network, but in this case rakuya nekunoko richienda uko. Preference yayo yana 70. So ndane two routes rine 60 nerine 70. The backup part nowhere if this one fails. So if you are looking at it, my route SR2I anenge arimo routing table because akasiyana ma preferences. Is this correct? Anenge arimo, yes. Saka iri rikadhakwa iri rine lowest preference iro ndo rinenge rakutonga zero packet rinenge rakuenda uko. That is what backup is. Ukasaisa backup iri rikadhakwa iri harikwanisi kuya nekunoko because that path is not installed in routing table. So a floating route is basically a route backup. Correction. A floating route is installed in the routing table only when the next hop of the primary router is unreachable. So rinenge riri routing table E1 iri. But as soon as this one fails, this one rinobva raiswa routing table because ndo rinenge rine the next best preference. So best practice kuisa backup rine a preference iri very close to static route yako. So ukaisa preference ye 120 panapa panogona wana imwe route ine lower preference ndo inoitwa backup basically. For best practice, this one should be as close to this one, to the static route, as possible. Then another example. RTA destination 20, this one, next hop, this one, preference is 60. No, it's the same example. It's the same example we've just did panel. So ndo link redu, if it is functional, this one is functional, then this is the case yekuti next hop yedu yadhakwa, then our backup rinobva rasumuka basically, rinobva raiswa in the routing table, rinobva ratanga function. So the idea behind my floating routes is pana you configure a static route rine a lower preference, therefore ikadhakwa ishi, this one will take over. CIDR, classless interdomain routing. When I look at this, I think of VLSM. So this is basically a method of efficiently allocating IP addresses, efficiently designing my subnets edu. That is what CIDR is. The one is get a wastage. Inoshansen's variable length subnet mask. So it's just a method of assigning my networks, assigning my IP addresses using variable length subnet mask. CIDR in an issue which leads or which requires need of what we call route summarization. Right. Subnet division and VLSM resolve the problem of address space waste, but also bring a challenge, increasing route entries in the routing IP routing table. Route summarization can minimize route entries. Right. Example. Taita ma subnets edu via VLSM. So you now have to my networks utu. Twangosiyana bichana. Dot 1, dot 2, dot 3, dot 4, dot 5, dot 6 ma subnets esata creator. We have segmented network yedu, yes, without wasting my addresses, yes. But however, routing table rinozara nemasubnets ese one. My routing entries akawanda. Trying to find the right route becomes very difficult. Configuring my routes actually becomes very difficult. Enter route summarization. Route summarization is basically summarizing my routes ASA. If I can say. In this example, the Kwanzaa summarizer is there no. Okay, I'll come back to example A. Let's look at something a bit more direct. How do we summarize? Summarization and calculation. So summarization, yada ufanana longest matching. So if you are trying to summarize 192.168.10.20.30, you realize with the longest match yedu inenge pana boundary 011011 pakasiyana 011 apo pakasiyana but kubva panapo kuenda ukweso kwakafanana for three maadresses are. Therefore, route summarization will say instead of having /24 boundary redu the network host portion rakuya panapa up inenge iri 8 16 17 18 19 20 21 22 /22. So I can summarize my networks SR to R3 using this network address. So summarization yakatofanana ne-longest match. Then the subnet mask will change depending nekuti boundary rako ramove raenda papi. Best explained in my examples. Let's have another example here. So we have 1, 2, 3, 4, 5, 6. Let's try to find a summary of those routes. Right. 192.168.1.0, then .2.0, .3.0, .4.0, then .6.0. We can see what of now. No problem. SIM slash 24. Right. Panotango siyana. The papa octet is now 1 2 3 4 5 6 6. So ndikatotarisa 1 2 3 4 5 6. First 4 bits is ma0 pana 1 2 3 4 5 6. So ma0 is 1 2 3 4 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So this is 1, 1, 2, 3. This is 1, 1, 2, 3. This is 2. Then this is 3. This is 4. Then this is 5. Then we have 6, I think. 0, 0, 0, 1, 2, 1, 2, 3, 4. So I think this is dot 1 dot 0 dot 2 dot 0 dot 3 dot 0 dot 4 dot 0 dot 5 dot 0 then dot 6 dot 0. So 192 image kwese, 168 image kwese, then 1 2 3 4 image kwese ishi apa pakafanana. Then ndotarisa aya mazero aya akafanana futi aya. Then paruzotanga kusiyana ndeapa 0 0 0 1 1 1 pakasiyana apa. So I can add another 0 iro. Boundary rangu riri panapa ndo pakafanana, ndo pane longest match pakafanana ma subnets angu esa. Ndochiverenga mask yangu ichabuda yakaita sei. This is 8 16 17 18 19 20 21. So I can summarize my networks angu ndichishandisa 192.168.0.0/21. Then was root summarization. So ndikada kuconfigure a route, for example, rinosvika kwese kunoko, ndinoenda ndongoti IP static route ndoisa 192.168.0.0/21 ndoisa exit interface rangu apa. So route rangu iri rese rinondisvitsa papi to any of these networks. That is what route summarization basically is. How to find it? Very simple. Match pakafanana pese and you summarize your routes. Panapa pana answer though. Iro rakaSummarize here. Right, panapa wakaSummarize. Let's try to summarize as well. Simplest way is looking at the first and the last one. So ndikataisa 10.1.1.0, especially karan in order. Are going to 1 2 3 4 5 6 to happen at 10. So the last one is not 10.1.10.0. Apa pakafanana but parunosiyana ndi apa. So ndikataisa 1 na 10, first 4 bits dzakafanana mazero aya 1 2 3 4 dzakafanana. Then ndikataisa 1 ndi 0 0 0 1. Then ndikataisa 10 1 2 3 4 ndi 8 0 1 0. This is 10. So you realize that pakangofanana ndi papa kudai sokuendawo. Saka root resummarized accurate summarization rinenge rina 10.1.0.0/ this is 8 16 17 18 19 20 rinenge rina /20 riri accurate. Mukatarisa riri panapa though rina /16. Iri rina /16 iri is very broad, rinokavha mamwe maareas asingakavhwe panapa. For example, 10.1.0.20.0 apa parinopinda pana /16 apa rinopinda, but it's not part of these ones. But 10.1.20.0 apa arikwana ipapapa. I think you can think of that with a little bit of practice. Kuti pane summarization inobata like umbrella, which is very broad. In this example, 16 iri rinobata aya rapa SI. It can summarize this. However, it also summarizes mamwe asipo ipapo. For example, iri haripo apa napa, but rinokwanisa kupinda ipapo. On the other hand, ukaita accurate summarization like this one, I don't think this one will able to fit in up. 20 ndiyani? If I try to look at it, the perfect example, 20 is 1, 2, 3, 4, 16. 16, 0, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So 16 plus 4. Uinde 20 ush. Uinde 20. But the problem yana 20 ndeyekuti 1 ush haanofanana ne-first 4 bits dzedu dziri panapa idzi. 0, 0 panapa pana 1. Zviro kuti does not match. Ndo pane issue yekuita accurate summarization. So this one is sort of broad. The umbrella covers one, but this one is specific. It covers exactly networks arapa. That's root summarization for you. Problems caused by root summarization. Root summarization there is some loops. So in this example, we can see how a loop is created. Let me see. We have networks kuno. I can see we have a default static route configured. Then we have a static route configured panap richishandisa route summarization. So they've summarized my routes esari into this route. Panap. So what happens if RTB receives traffic destined for 10.1.20.0 and forwards the traffic to RTA according to the default route? Right. Perfect example, this one. So, panapa posika traffic is destined to 10.1.20. Router redu, what does it do? It goes and look at its routing table. Routing table yayo, yoona ma directly connected interfaces arapa. Apana 20.0. Ikashaya. Then yoshandisa the default route to send out this interface via this next hop IP address irapa. Information of your panapa. Packet rashiga panapa. It's still destined for 20.0, 10.1.20.0 network. Parinosvika panapa, tikatarisa murouting table. Murouting table mune route iro reinstalled iro. Route iri rinokava part of this. Umbrella number rinokava this. Iro route iri. So what does that mean? Router iyi ichaforwarda back kunoko because of this static route. Radzoswa kunoko. Pama networks aya. Iyi network haipo. Zviro kuti tikadzoswa panapa, richadzoserwa futi default. Rovha radzoserwa uko. Richisvika panapa, because of this route resummarization, richafungidzira kuti rinofanira kudzoserwa uko. Then that's how a loop is created. Problem number 1 iripo apa, inyaya kushandisa an inaccurate summarization. Dai pakashandiswa summarization iri correct instead of putting 16 apo pana 20. Paisa create that loop because the moment yanosvika apa 10.1.20.0 haikwani kana pana 20 apo. Zviro kuti haichadzoserwa kuno. But since taita incorrectly summarize, loop rato create no problem iripo. Solution ndekushandisa inonzi now zero interface new zero interface. So basically that interface what it does, it creates a black hole where if a packet is received and its destination for it matches that route entry, it gets dropped automatically. So zvakatitaura network yedu 10 10.1 10.120.0 10.120.0 slash 24. So problem yange iri kuitika ndeyekuti packet destined for this network kana riri kubva panapa raishandisa this kuti riuye uku, parinosvika panapa roshandisa this kuti ridzoke uku, parinodzoka panapa next time, instead of using this default route runoshandisa chi now interface iro rirape ndo rinotanga kumecha iroro. So rikamecha now interface rinobva radrop, ndoku kustopa loop kwatinoita. But I think this with accurate summarization could not be a problem. Maloop anocreatwa kana wada kusummarize broadly, wada kubata with sort of an umbrella thing, kubata ma subnets akawanda. That's incorrect summarization. Ukada kudaro unocreate maloops like in this case. Accurate route summarization, I think this is what I was speaking of. You need to have accurate route summarization. In this example, if you look at summarization in my routes, I think it will give you, this is 1 0 0 0 0 0 0 0 1. This is 1. This is 31 0 0 0 120 64 32 1 1 1 1 1. This is 31. So ndikada summarize maroute ayo boundary rangu rinouya panapa ndo pane mamatch akafanana. So meaning summarization yezvese zvirapa izvi is 172.16.0 again slash instead of 24 tinenge tana 16 8 16 17 18 19 ndo correct summarization. However, mukashandisa route iri rakaitwa kunge irero rina 16 iro, that's incorrect. Zvichaitika ndezvekuti even maroutes ari panapa aya anokwana futi ipapa pana 16 apa, anokwana as well pana 16 apa, pana 19 haakwani. Let me summarize ari kunoko futi. Let's have proper summarization ari kunoko. So iyi summary ari pamusoro iyi ari pazasi aya I think anosiyana panapa 32 to 63. 32 is 120 64 32 1 2 3 4. This is 32. Then 63 is 0 128 64 1 2 1 2. This is 63. Then pakafanana and up boundary rangu rapana. So meaning 172.16.0.0 slash 8 16 17 18 18. So summary yepanapa and ish accurate. Then summary yepanapa and ish accurate 19. So you can see kuti SR2I 18 and 19 they can fall under slash 16 easily. So your route rako kwayo configure na slash 16 like this. If information is destined for this network, anokwana pana slash 16. If it's destined for this network, arapa, anokwana futi pana slash 16. So you have an issue, for example, yekuti information ufana kuya kunoko. But since route rakaconfigure E1 rina 10.0.0.2 rukene kunoko, traffic irufana kuya kunoko inongoforwardwa uko, yaforwardwa uko ichanoite ikoko, ichanokonzeresa maproblems ikoko. But ukaita accurate, ukauya ukaisa 19 panapa instead of 16, there is no way yekuti traffic iri destined for kunoko it ends up yakuendeswa uko because of 19 year yarapo. I think that's the issue to do with accurate route summarization. Hopefully it's making sense. If it's not making sense, sit down, digest. You will see the error iripo papa route summarization ipapa. Accurate route summarization. What do we have here? Right. Panapa, I think the perfectly correctly summarized route redo 2 minutes. We won't be able to finish. They correctly summarized route redo /22. So, kubatanidza SR3 anosummarize on a /22. That's accurate. Iwo ukadoma summarize on a 10, 1, 1, 0, 16 instead of 22. Unongo waisa boundary panapa. So unongo wabatanidzira zvese izvizvi zvisiri kufanira kubatanidzirwa basically. That's the idea. Iyi ndo 16 ichi, iyi ndo 22 iyi. 16 inoshanda, but unobatanidzira with mamwe masubnets which are not part of these ones. Arapa. That's the idea behind accurate summarization. Database. If we still have variable quiz here, you can answer 1, 2, 3. Freestyle. 2 minutes left. If you don't answer, no problem at all. But you can as well try. We can try to summarize this one. Multiple answer. Let's try summarizing that. 10, 1, 1, 0. The people answered on 2 minutes. We're not going to summarize. Let's just run down 2 minutes here, Sarah. Give me answers for any of those questions. I'll wait. I felt like responding to this, but I don't think my time will be enough. So 10, 10, 10, same. 1, 1, 1, same. Then 1, 3, 9. Almost how binary. Time won't be enough, but we're just running it down. 1, 2, 3, 4. This is 3. Then 1, 2, 3, 4. This is 9. So arufanana uskapana. Dopa arufanana. This is 8, 16, 20. So this is 10.